once you've finished that first AP free response assignment, the solutions are actually on Haiku right here. And we'll kind of go through the first one together. Remember that there were 6 requirements, 6 skills that we've learned that this assignment is really testing you on. We're going to be on the lookout for them as we go through today. Now, one thing that I find helpful when doing an assignment like this is to explain what the purpose of each part is. That's where I find the most help in this. One of my goals for doing this together as a class is to give you some sort of toolkit that you can use to break down a big problem. So we have 2 methods to write. The frog simulation class provides a method called hop distance that returns an integer representing the distance, positive or negative, to be moved when the frog hops. This class already has a method that's going to give you a positive or negative number that's telling you how far a frog is hopping. A positive number represents a move towards the goal, negative represents away, and the return distance may vary from call to call. So, for example, if you look at each of these examples, you can see that maybe they're giving you a couple of bumps in a row, telling you first it moves 5, then 7, then 2 back, then 8. We're going to get a bunch of these hop distance calls in a row. What simulate does, the method that you write, has the frog hop up to its maximum number of times and gets a value from hop distance at each hop. It's going to hop up to that maximum number of times and give a value from hop distance. The simulate method then returns true or false that represents whether the frog has met its goal distance under its maximum number of hops. Okay? There's some examples right here. So what I'm actually going to do to start this out, here's my answer. Before you look at anything, don't look at the solution. I'm going to write down what simulate is supposed to do. I'm going to put it in my own words. Simulate calls hop distance a bunch of times up to the maximum number of hops. Hop distance returns basically a random number. We want to check to see if we made it. The goal distance. Now, here's the last important part. At the top of your class, we had 2 private variables. We have an int goal distance that represents the goal distance, and we have an int max hops that represents the maximum number of hops we have. We have access to these. I think that's really helpful. Okay. So, question is, how do we write a solution? First things first. It's a Boolean. We know we want to return true or false. We want to return true if our total distance meets the goal distance, not return false. The first thing I'm going to do, maybe for my own sanity, is say check if we met the goal distance. Now, normally, for a Boolean, we would make a Boolean value. We could do that, set it equal in each of these, and then return it at the end. But I definitely need some sort of number that's going to keep track of how far this frog travels. So I made one called total distance. That'll be what I finally compare it to. Now, here's the key. How many times have you added up the sum of something? You've done that a million times. All you do is do plus equals inside of your for loop. The weird part about this is that it calls hop distance each time, which returns an integer. And how many times do I want to run this? I want to run hop distance up to our maximum number of hops. And that way, it'll check to see if we've met our goal so far. So we'll go through this one more time. Simulate should run hop distance a bunch of times up to our maximum number of hops. That's what this for loop does right here. And it's going to check and see if we made it. And if it does, return true. Otherwise, return false. Next, we have the second part of our problem. Which is part B. Okay, write the run simulations method, which performs a given number of simulations and returns the proportion of simulations the frog successfully reached the goal. For example, if the parameter passed to run simulations, this parameter num right here, is 400, and 100 of the 400 calls return true, then the run simulations method should return 0.25. So what we want to do in this method, I'm going to do just what I did before. I'm going to write the purpose of it first. Calls simulate returns a Boolean. Num times and returns double that represents the amount of which it's true. So it returns a double, but I want to count the number of true things. So I'm going to make an int named count at first. And I want it to run simulate num times. So I make a for loop. That runs simulate num times. And if simulate is true, if simulate's true, I add to the count. Okay, pretty straightforward stuff we've learned so far. I add to the number of counting things from, or no matter how many times that simulate returns. Here's where it gets tricky. The goal return the proportion. Proportion means divide, right? 100 divided by 400. The problem is that if count were an integer named 400, or named with a value of 100, say, and num, the total times were 400, like the example gave us, 100 divided by 400 when they're both ints is not going to be equal to 0.25. What's it equal to, class? You're totally right. It's equal to 0 because it truncates. Integers truncate. The reason that I picked this problem is because it requires you to pass the answer as a double from an int, which is a little bit of a blast from the past, but something you might totally have to use on the AP exam. Remember, this was in our first of the 8 units this year. So hopefully you came up with something that looks a little bit like this for the two problems. This was problem number 3 on last year's AP exam. And I think it tests you on a lot of the skills that are listed at the top in this assignment. In fact, I want to see real quick if you know where these skills are used before we move on to our second answer and assignment. So there are 6 things that this assignment's going to test you on. Say, number 1, writing if statements to check if one or multiple statements is true. I want you to scroll down to your answers for part A and B, and I want you to show where each of these 6 statements is being used. Remember we said if statements were that for the first one. So I'm going to go to my answer. I'm going to make another comment. I'm going to put copy and paste number 1, writing if statements to check if one or multiple statements. It also happens in part B. So I'll put it down there. I'd like you to go ahead and pause the video and take about 3 or 4 minutes. Look at those 6 skills, and for all 6 of them, make a comment on your own answer to number 1 and show where each of those skills is being used. Go ahead and pause. Start again when you're ready. Last but not least today, it gets a little trickier with problem number 2, APFRQ number 2. Class called AP Calendar. This is from the AP exam 2 years ago, and I want you to take a full 22 minutes on this. Just like the last assignment, this assignment starts with, if you want to pause the video right here and look at the class first, you can. Looks like this AP Calendar class already has some methods that work. The first is a Boolean called is leap year. The second is an integer return statement that says first day of the year. And another return statement called int, called day of year, that tells you what number of year it is. Okay? It wants you to write 2 methods today. First day of year, or I'm sorry, number of leap years, count the number of leap years, and day of the week, which returns a number that represents the day of the week. Now, I'm going to give you one hint for this assignment. Actually, you'll notice at the top on this one that says inclusive. Okay, that means that like if 2000 is given, as if you're counting the number of leap years between 1980 and 2000 is a leap year, you should count it. Second, think about where the modulus would be helpful, the 2 parts of this problem. Just like your other assignment, it gives you 2 helper methods you're going to want to use. First day of year and day of year, with examples to how they work. With examples for how they work in the middle of the problem. So if it's helpful, you can open up the slides on Haiku. You can time yourself 22 minutes using my last slide. And when you're done, I want you to read the rubric and grade your own assignment. Under number 3, the rubric is attached right at the bottom. The first of the 2 methods is worth 5 points, the second is worth 4. Say, for example, the first point you can earn for initializing a numeric variable. You'll go to the answer that you wrote for in part A, and you'll make a comment and put in that category, just like you did for the skills before. Then you'll submit this on Google Classroom, and you're done for the day. On Thursday, we'll do our first little graded assignment. Just like this. Hopefully this is a little bit of a blast from the past. For these 2 problems, if you want to talk through them, office hours can be a great idea, since you won't really have the chance to do that for your little graded assignment on this type of problem on part 3. This is really good practice on stuff we learned earlier in the year, like using methods and calling methods from other places in code, using for and while loops and if statements, and thinking about how methods are going to work. And I can almost guarantee you'll have a problem like these 2 on the AP exam, because both of these are straight off the ones from the last 2 years. Good luck, thanks for joining today, and keep up the great work.